So hello students, welcome once again to our series. See, as I promised, as I said that I will be taking up one or two more questions. So that's the next question again based on functional relation. What are we given here? We are given here that f of x into y. So f of xy is fx times fy for all x and y belonging to R, okay, and we are given f dash of 1 to be 1, f1 is not equal to 0, we have to find out f dash of 3, so that's the question. See, we have already seen one approach in solving such type of question with the help of partial derivative. As I said, we will be discussing it with the help of first principle of differentiation here, okay. See, now in both the cases, any one of you can think or may ask that how we come to know that we have to use differentiation. See, for that I will say any information related to derivative. In the previous question, if you remember, we were given, I think f dash 1, something was given, f dash 1 was 2 or something like that. Here also we are given f dash of 1. It's not like f dash of 1 is important. The important point is that we are given the derivative of the function at some point. So that's a clear-cut hint for the use of differentiation here. So you can use it in the form of partial derivative as we did in the last question, or we can use it in the form of first principle of differentiation. So let's start. So how can we do it? We'll say we know that f dash of a is using first principle of differentiation, limit h approaches 0, f of a plus h minus f of a over h, bachcho. That's what we know for f dash of a. Okay, now but the point here is that how can we use this information, this relation, to simplify anything here. Okay, since the information is given for product of two input, so how can we use it? So for that I will say let's rewrite the first term of numerator as taking a common from it, so 1 plus h of a. So I could rewrite the input of this thing as product of two terms, a into 1 plus h of a minus f of a over h. So now what? So therefore f dash of a is equal to limit as h approaches 0, so fx into y. As given in the question, it is fx into f of y. So it is given fx, so f of a into f of 1 plus h by a minus f of a over h. Now see, the variable of limit is h, so and we have fa common, so it will come out of the limit. So taking it out, so limit as h approaches 0, f of 1 plus h by a minus 1 of course upon h here. Okay, now how to use this information? So this information, let's rewrite it in terms of first principle of differentiation. Okay, so we can write that f dash of 1 is limit h approaches 0, f of 1, a is 1 here, 1 plus h minus f of a, which is 1 upon h. Clear? Now we have something similar to it. We have h in the denominator, 1 plus h of a. Okay, that we can balance by dividing and multiplying by a. The problem is 1. We need f of 1 here. So for that, let's check the value. So I will suggest you all to put x and y both 1 in the given relation. So we get f of 1 is equal to f of 1 whole square. Now see, we are given that f1 can't be 0. So what's the other possible value of f of 1? So this implies f of 1 is 1. Okay, so hence we got it. Now put it there. So therefore we can write f dash a is f of a limit h tends to 0, f of 1 plus h by a minus f of 1 over h by a into a. Now h by a can be our new variable, as h tends to 0, h by a also tends to 0. So I can write again, see, from denominator also I will take out a, and as I said, let us say h by a is t, new variable. So it's f of 1 plus t minus f of 1 over t, and this is nothing but f dash 1. So f dash a is fa by a into f dash 1, which is given to be 1. So now it's true for any a, so therefore this imply I can write f dash x is fx by x here. Now we can easily integrate, so integrate it to get your fx. So integrate to get fx bachcho. Okay, so that's it. And I think this information is an extra information. Okay, that there might be some typing error here, so you may just simply skip it, because see, you will have only one unknown after integration, and to get the value of that unknown we already have a relation f of 1 is equal to 1. Okay, so that was again a question based on functional relation where we use the first principle of differentiation bachcho.